Hey everybody, so today we're going to be talking about areas of similar figures or similar polygons. Okay, so we learned about the perimeter and how it's proportional to the scale factor, or that ratio between corresponding sides. And today we are going to learn about how the polygons, if you have two of them that are similar, the areas are proportional to the square of the scale factor. That's the biggest difference between area and perimeter. Right, area is going to be that scale factor squared. And what that looks like, you would have your area of your green shape over your area of your blue shape, equaling that scale factor squared. Okay, one way that you might see the scale factor written in an equation might be K if it's a missing value. Okay, so let's look at an example. So if we have a triangle JKL is similar to PQR, I'm going to color coordinate these for you guys. So JKL is blue, PQR is green. Right, the area of JKL is 30 square inches. We want to find the area of PQR. So first we want to start off with the scale factor. Okay, so the scale factor again is the ratio between corresponding sides. So the scale factor between PQR and JKL is 15 over 12, or when reduced, 5 over 4. Right? This order is very important because the order of our scale factor has to directly correlate to the order of our area in the proportion. Okay? So if we know that the area is green over blue, we're going to do area of PQR over the area of JKL. Okay, they need to match our scale factor. Okay, so equals, we determine that it's 15 over 12, 5 over 4. There we go, because we reduced it. Right? The thing is, though, since it's area, we need to square our scale factor. Okay, so go ahead and square that. So we're going to say the area of PQR, which we're looking for, we'll call that X, over the area of JKL, which is 30, equals our scale factor squared. Okay, so we're going to distribute this exponent to both values of our fraction. Okay, so 5 squared is 25, 4 squared is 16. Okay, so when we cross multiply and solve this out, we get 16x equals 750. And then after dividing 16 from both sides, we will see that x equals a total of 46.9. Okay, so that means that the area of triangle PQR area is 46.9 units, or in this case, inches squared. Okay? One more example like this. I apologize, we're going to be going in between different slides back and forth. Okay? So here we are given two similar triangles. We want to find the area of the shaded figure. Okay? Just for consistency purposes, I'm going to color code the different triangles so that we can keep our images straight. Okay, so we want to find the image of our shaded figure. We're going to call this P. And the unshaded figure will be blue, or B. Okay, so we know that whenever we have area, our scale factor has to come into play. So we're going to look at our corresponding sides. We're going to say, first step, figure out our scale factor. Okay, so our scale factor we can say is side B over P, or 20 over 30. Okay, when we reduce that, we get a total of 2/3. Okay, so our scale factor is going to be 2/3. Now, why we need our scale factor? Remember, we know the area of one polygon is proportional to the area of the other polygon, all right, or the scale factor squared, okay? So we're just going to say our scale factor here is 2/3 squared, okay? So the areas is proportional to the scale factor. Okay, so we're going to go the area of B, which is 200, we're given that, over the area of P, we're looking for that, equals, simplify that square down, so we get 4/9. Okay, now we just need to cross multiply. Okay, so we're going to get 4x equals 1800, because we cross multiply both sides. When we divide by 4, we are left with x equaling 450, okay, or the area of P, or our shaded polygon. Okay. So moving on to our last set of examples. Here we are given area values, but we need to find the scale factor. Okay, so it's unknown, we're going to call it k, and we need to find the value of x. Okay, so like I've done before, I'm going to color code for you guys to keep it straight. Okay, so we're told the area of ABCD is 150 square meters. FGHJ is 54 square meters. Okay, we are given that these two polygons or quadrilaterals are similar, okay, which means they are proportional. We need to find our scale factor of FGHJ to ABCD. Now look here, order is very important, okay? FGHJ is our blue shape, and ABCD is our green shape, okay? So setting up that scale factor, our proportion, we need to have it in the correct order, okay? So again, we're going to have K be the scale factor between the two images, okay? We're going to say the area of shape FGHJ over the area of ABCD equals the scale factor squared, or in this case, K squared. Okay, so the area we are given is 54 over 150. All right, we also can tell that if you factor out a 6 from both of these, you're going to get a simplified ratio. Okay, so 9 over 25 equals K squared. Okay, so let's draw a line. So this is our new equation right here. So this is our areas, this is our scale factor. Now we need to get rid of this exponent so that we have just a solitary scale factor. Okay, so in order to do that, we want to take the square root. When you take the square root of a fraction, you take it from the top and bottom. We're going to be left with k equaling 3/5. Okay, so we found our scale factor. That's what we needed to find. And now we have enough information to find that missing side here on FGHJ. Okay, so we need to take our scale factor, set up a proportion, because remember, all the scale factor is the corresponding side length. Okay, so we set up our scale factor as blue over green. So I'm going to say 3/5 equals our missing side length x over 10. So just setting up that proportion. And now we're going to multiply. Okay, so we get 5x equals 30. When you divide by 5 on both sides, we get x equals a side length of 6. Okay, so x here on this shape would be 6. One more example. Last example. So here we are given two areas. We want to find the scale factor. If it's hard to tell what you need to do, underline what the question asks you. Find the scale factor from the unshaded area to the shaded area. And then also we need to find x. Okay, so here we are going from unshaded to shaded. Just to keep up with the consistency purposes, I will color the images for you so you know where the numbers come from. The unshaded will be purple, and the shaded will be pink. We will call them S and P. So we can say the we're going from unshaded to shaded, so we're going to put the unshaded area first. Area of unshaded over area of shaded is going to equal our scale factor squared. So like before, when we have a missing scale factor, you can put it as k. So in order to solve these out, we're going to plug in our area values first. So 70 over 30 equals k squared. Okay, we can simplify this 70 over 30 to 7 over 3. Alright, so 7 over 3. Set that equal to k squared, or our scale factor squared. Now we just need to solve for the scale factor alone, or just k. Take the square root of both sides, and we get that k is equal to the square root of 7 over the square root of 3, which is going to be, square root of 7 is 2.65 over the square root of 3, which we get is 1.73. Okay, so this is our scale factor between our unshaded and our shaded area. Now the last thing we need to do is find that missing side, x here. Okay, so our scale factor was set up in terms of purple over pink, or unshaded to shaded. So we're going to say 2.65 over 1.73 will equal x over 7. Okay, because again, we need the scale factor and our areas to correlate directly, be in the same exact order. Right, last thing left to do is to cross multiply and solve. So we get 1.73x equals 2.65 times 7. Okay, so that comes out to 18.55. And then when we divide both sides by 1.73, we get a total of x equaling 10.7. Great job today.